Section 8.3. We had a complex number, we might have called it z, equals a plus bi. And we graphed these things where real numbers went on the x-axis and complex numbers went on the y-axis. So if I had like z equals 5 plus 2i, I would graph it right here. Here's the point, 5 plus 2i. And then we learned that we could write these in polar form. So we needed to figure out this length. In polar form, we called that r. When we were dealing with complex numbers, we called that the length of z. The length of z, we defined it to be the square root of a squared plus b squared. So in this case, it's the square root of 5 squared plus 2 squared, which is the square root of 29. And then we needed, for polar form, this angle theta. How would I find theta? Not the Pythagorean theorem. I use the Pythagorean theorem to find the length. Got a little triangle right here. How long is this distance? How long is this distance? 2, really, 2. So if I know this is 5 and this is 2, what can I do with this theta? Tangent. So tangent of theta is 2/5 y over x. So theta, we would grab our calculators. I don't have mine right here with me. Tangent inverse of 2/5. Somebody tell me the tangent inverse of 2/5, please, approximately. 0.381. Okay, so this point, 5 plus 2i, written in standard form, could be written as square root of 29 times cosine of the angle plus I times sine of the angle. And that's what we called polar form. So we wrote our complex numbers in polar form like so. And then we talked about we had a reason for doing that. What was our reason for writing numbers in polar form? Something important. All right, so let me give you two easier numbers in polar form to deal with. Like z1 is, let's say it's 5 cosine 20 degrees plus I sine 20 degrees. So there's one number. And here's another number, z2 is, I don't know, give me a number you like. 3 cosine, give me a nice angle, 45 degrees plus I sine 45 degrees. The reason for writing these numbers in polar form like so is it was very, very easy to multiply and divide. How do we multiply two numbers when they're in polar form? Well, we saw we had a rule that said multiply these things in front. So I take 5 times 3. 15. Yeah, people get that one right usually. And then, what do I do with the angles? They don't cancel out, unfortunately. You add the angles. So it's going to be cosine 65 degrees plus I sine 65 degrees. So multiplying in complex form is very, very easy. You multiply the numbers out front, and then you add the angles. Dividing was also very, very easy. How do I divide two complex numbers? What do I do with the numbers out front? I divide them, so it's going to be 5/3, and then you're exactly right, I subtract. So it would be cosine of negative 25 degrees plus I sine negative 25 degrees. So that was our reason for writing things in polar form. Writing them in polar form made multiplying and dividing very, very easy. It also made exponents very, very easy. Like, let's say I wanted to do z2 squared. So basically what I'm saying is, take this point and multiply it by itself. Well, how do I multiply again? I multiply the numbers out front, so I'm going to have 3 times 3, so I square that number, that's 9. And then I'm going to have cosine 90 degrees plus I sine 90 degrees. What if I wanted to take z2 and cube it? Where do they get the 90? 45 plus 45. Because if I'm multiplying it by itself, I add the angles at 45 both times. I just added it again. So if I want to cube it, I take this number and I cube it. So that's 27. And then what do I do with the 45? I times by 3. So if I want to cube a number, I cube the number up front and I multiply the angle by 3. 135. So cosine 135 degrees plus I sine 135 degrees. All right, so I think that's where we left off. The thing we hadn't talked about is, how do you do roots? That's correct. What do you do with the angles? All right. So here's the rule. I'm going to write it down so I make sure I match what the book has. The same way. So if you want to take a complex number z and raise it to a root, 1 over n, you're going to take the number out front, which is usually called r, and you're going to do its root. And then you're going to have times, like square root of z would be z to the 1/2. The cube root would be z to the 1/3. We write it that way. So you're going to have cosine of your original angle theta plus 2k pi all divided by m. We'll talk about what these things are in a second here. Plus I sine theta plus 2k pi all divided by n. Or if you were working in degrees originally, you would have the r to the 1 over n still. Then you would have cosine of theta plus 360 degrees times k divided by n plus I sine theta plus 360 degrees times k all divided by n. Alright, so give me a complex number that you like a lot. Z equals. Anybody got a favorite complex number? 83 over 2? 83 over 2. That was going to be my first question. Is that a complex number? Why not? So what does it have to be a complex number? What makes a number a complex number? Square root of what? No. Square root of a negative, which gives you a I. So what makes a complex number is it has an I in it.
Yeah.
Does it have an I in it?
No.
Sure?
Pretty sure.
Pretty sure? I could add a 0i. So now is it a complex number?
Yeah.
It is a complex number. So real numbers also are complex numbers because I can write it as the real part plus 0i. It's cheating, all right. I'm glad you agree. But it is a complex number. So what we need to do in order to find roots of this complex number, well, we don't really need to, but we're going to, we need to write it in polar form. Well, the length of this complex number is 83 over 2. Because it's a real number. Cosine, what's the angle for 83 over 2? Alright, think of the graph. Where is the point 83 over 2 plus 0i? Where is that on the graph? It's right on the x-axis, isn't it? This is 83 over 2 plus 0i. So what's the angle for that point? 0. Cosine 0. Is that radians or degrees? Both. Correct. I couldn't trick you with that one. Plus I sine 0. All right. So this, because we picked a real number, that's not very interesting. Because how do I do square roots of a real number? Do I need to write them in polar form? Do you know the square root of 83 over 2? No, but I can put it in my calculator and I can get a decimal. All right, so 83 over 2 wasn't a very good number. Well, I'm going to pick a different number. Z equals 4i. Is that a complex number? Yes, that one you like as a complex number because it has an I in it. All right, first thing we need to do is we need to write that in polar form. It's right here. It's really 0 plus 4i. So how long is it? How far is it from here to there? The length is 4. Cosine, what's the angle? 90 degrees. Or pi over 2, which one do you want to use? Chickens. 90 degrees plus I sine 90 degrees. Okay, so if I want to do the square root of 4i, that's 4i to the 1/2 power. And according to this rule up here, if I'm dealing in degrees, I take the distance, our distance is 4, and I do it to the 1/2 power. So that's going to be 4 to the 1/2. And then I'm going to have cosine of theta. Theta is 90 degrees. That's what we started with. So it's going to be 90 degrees plus 360 degrees K over N. What's N? Can I move the paper so you can see what I'm writing? Sure. What's N? N is this N up here. So N in this problem is 2 because we're doing square roots. That's 2. And then I didn't leave myself enough room, so I'm going to sneak it in down here. Plus I sine 90 degrees plus 360 degrees K over 2. All right, now what's this K? Well, if I'm doing square roots, how many answers should I get? 2. Like, what's the square root of 9? Plus or minus 3, there are 2 answers. So if I'm doing square roots here, I should get 2 answers. So what I'm going to do here, since I'm dealing with n equals 2, I'm going to plug in k equals 0, k equals 1, and that'll give me 2 answers. What if I was doing a cube root? How many answers should I get? How many cube roots are there? Three is your final answer. How come? That's a good guess. All right. So if I'm doing cube roots, I'm going to have a 3 down on the bottom here. So k, I would plug in 0, 1, and 2, and I will get 3 answers. So there are 3 answers to a cube root. So what's the cube root of 8? 2, 2, and 2? No. 2 is one of the correct answers. What are the other 2? No, because 4 times 4 times 4 definitely doesn't give me 8. Negative 2 times negative 2 times negative 2 does not give me 8. All right, so we'll figure those out in a minute. All right, so I just said there are 3 cube roots. You can only tell me one of them. All right, let's finish this problem first, though. All right, so I use 2 numbers. I use k equals 0 and k equals 1. First off, what's 4 to the 1/2? Because I should get 2 answers. So I pick my 2 easiest numbers in the whole wide world to work with. I could use any 2 k values. I could use k equals 5 and k equals 6, but those numbers are harder to plug in. So I pick easy numbers. Yes. All right, so 4 to the 1/2, that's 2. And then what's 90 plus 360? Oh, no, I'm sorry. K is 0. What's 90 plus 0? And 90 divided by 2? 45. So I'm going to have 2 cosine 45 degrees plus I sine 45 degrees. So there's one of the square roots of 4i. I'm very happy that that's an answer, yeah. And here's the other answer. No. What's 4 to the 1/2? Still 2, isn't it? Now I'm plugging in 1. What's 90 plus 360? $450. What's 450 divided by 2? 225. So I'm going to have cosine 225 degrees plus I sine 225 degrees. Questions on that? If I were to graph these 2 square roots, where would they be? Well, the first one has a length of 2 and the angle is 45. So where's length of 2 and angle is 45 degrees? It's kind of right there. So this is the first square root. Where's angle 225 degrees? Where's 225 degrees? Which quadrant is it in? It's in quadrant 3. And it's the opposite of, kind of the opposite, so it would be right here. Okay, so notice, if I do square roots, they're kind of evenly spaced around, aren't they? I mean, this is 45, and then this is 45 here, so they're kind of evenly spaced. All right, so let's do the square root of, the cube root of 8. No, what would happen if I picked k equals 2? I would get something coterminant over here. It's just, my angle would be 360 plus 45. And if I used k equals 3, I would get this dot again. You're only going to get that line for square root. For square root, you'll get 2 answers. They'll be evenly spaced. All right, so let's say I gave you z equals 8. And I wanted you to cube root of. That's better. All right, so the first thing I need to do is I need to take the number 8 and I need to write it in polar form. So what's the length of the number 8? It's 8. And what's its angle? Is that degrees or radians? Both. So cosine 0 degrees. We'll work in degrees today, I guess. Plus I sine 0 degrees. Chicken, I know I said the same thing you did. All right, so to find the cube root, I'm going to have the cube root of 8, and then I'm going to have cosine of 0 degrees, my original angle, plus 360 degrees k divided by 3. Go ahead, I'm listening.
So you said that 2 was 1.
2 is one of the correct answers.
Is positive 8 to 1/3?
Well, 8 to the 1/3 is a fancy way of saying 2. No, that's not one of the answers. 0 degrees plus 360 degrees k over 3. All right, so this time we got to plug in 3 values for k. We plug in 0, 1, and 2. When I plug in 0, I have 8 to the 1/3. What's 8 to the 1/3? 2. I plug in 0. What's 360 times 0? What's 0 plus 0? What's 0 divided by 3? What's cosine of 0? It's 1. And when I plug in 0 here, I have 0 plus 0 over 3. What's 0 plus 0 over 3? Still 0. What's sine of 0? What's 0 times I? 0. So I have 8 times, or I have 2 times 1 plus 0. So there's where we get 2. There's one of our answers. All right, now I plug in 1. I still have 8 to the 1/3. 8 to the 1/3 is still 2. Then I'm going to have cosine. What's 360 times 1? What's 360 plus 0? What's 360 divided by 3? 120. 120 degrees plus I sine 120 degrees. Finally, I plug in k equals 2. 8 to the 1/3, that's still 2. Cosine, what's 360 times 2? It is 720. 720. What's 720 plus 0? 720. What's 720 divided by 3? 240, that's correct. All right, so notice what happened. When I asked you what's the cube root of 8, you immediately told me one of the answers is 2, which is correct. What can you tell me about the other 2 answers? Holy moly. One's in quadrant 2, one's in quadrant 3. The important thing is they're complex numbers, aren't they? So one of the cube roots is a real number. The cube root of 8 is 2. The other 2 cube roots are complex numbers. They're imaginary. They're complex numbers. But I want you to notice something here. Again, if I were to graph these, here's 2. Where's this point? You told me it's in quadrant number 2, and it's 120 degrees. So this is 90, this is 30, so it's kind of up here. So here's the second point. And where's the third point? At 240, so this is 180, so it would be 60 more. Notice again, oh, well, those dots didn't come out good. But what you should see is they're evenly spaced around the circle. Just like the square roots were evenly spaced around the circle, cube roots are also evenly spaced around the circle. I could draw like a triangle, I suppose.
See, there's no way to get more than 3 now. I would say, well, you can literally think of the number of roots, though.
So you're right. Well, I mean, it's hard to do an infinite number of roots. But what if I were to do a 4th root? How many answers would I get? 4. And again, they would be evenly spaced. You would get 1, 2, 3, 4 fourth roots. If I did the fourth root of 8.
But so eventually,
Correct. So if I keep going, if I do 5th root, 6th root, 7th root, if I let n get bigger and bigger and bigger, my dots are going to be evenly spaced around the circle, and you're right, they would be closer and closer to a circle the bigger I let n get. So if I did like the millionth root, I would have 1,000,000 dots evenly spaced around the circle, and it would look, for all intents and purposes, like a real circle.
and how the lines would they plot them all?
I don't know which lines you mean.
Your imagination.
Oh,
Would they like make a vortex into the side of it, or would they just?
well,
Yeah, like how would the real ones?
again, if I had 4 points and I connected them,
Okay, so they don't look like.
I would have something like that. Then if I had 5 evenly spaced, I would get a pentagram. Pentagram 5. But you can see it's getting closer and closer to a circle, isn't it? These lines are getting shorter. If I had 6, it would get closer to a circle. So on. X. Hexagon. This is also called a pentagon, called a pentagram. That's two. Yeah. All right. Anyway, that's taking roots of complex numbers. Yeah, but if you draw the star,
I know that it makes sense.
and then you connect the things, you see,
That's a pentagram.
it's a penta something.